Welcome. The topic we'll be discussing in this lecture is overview of ad hoc routing protocols, and also we'll be discussing a brief introduction to wireless sensor networks. So ad hoc networking has attracted a lot of research over the last few years, and this has led to the development of many new routing algorithms, and all these routing algorithms have uh, it has its own advantages and disadvantages. But broadly, these routing algorithms can be categorized under three headings. These are flat routing, hierarchical routing, and geographic position assisted routing. Okay? So the routing algorithms that are used with ad hoc routing networks can be classified under three categories. These are flat routing, hierarchical routing, and geographic position assisted routing. Okay, coming to flat ad hoc routing, with flat ad hoc routing, these protocols do not set up any hierarchical structure, like there is no cluster heads or there is no special node acting as a head or something like that. Every node will equally participate in routing. So the routing is flat and the addressing scheme is also flat. This category, again, it falls to two different subcategories. These are proactive routing algorithms and reactive routing algorithms. Basically, these proactive routing algorithms, they they include some routing table, and they keep updating the routing table, and they keep transmitting information about routing table. So such type of algorithms will be included in proactive protocols. They set up tables required for routing regardless of any traffic that would recur. Okay, so DSDV is one of the member of this. Here it is not included, but we have discussed direct destination sequence distance vector routing algorithm. So that is also a member of proactive routing, DSDV. Okay, because it maintains routing table. It used to transmit uh, the state of the routing table always. Okay, right? So DSDV is a main member of this particular class, and many protocols belonging to this group are based on link state algorithm. Okay, so link state algorithms, they normally flood the information about neighbors periodically. In mobile ad hoc networks, this method actually exhibit several drawbacks, because in mobile ad hoc network, you cannot flood the network with the information about the neighbors even when there is no data communication, because then the network is not used efficiently, and also the battery of the devices will get discharged quickly. Okay, so uh, so so this is the drawback with this approach. Okay, so there are algorithms like fisher state routing algorithm and fuzzy cited link state routing algorithm. So these algorithms were proposed to reduce the amount of updates that were done in the context of uh, updating the routing table. Okay, so these are some of the improved versions, which ensures that the routing updates were reduced. Okay, so this routing algorithm, what it does in the sense, routing entries corresponding to faraway destinations are propagated with low frequency, and the routing updates about the closer nodes are propagated frequently. Okay, so and so they frequently share the information about the nearby destinations, but they share the information about the destination nodes less frequently. The result is that routing table reflect the proximity of node very precisely, while imprecise entries may exist for the nodes which are further away. Okay, so this is how this algorithm works. So other link state protocols that try to reduce the link state information. So link state information is about the routing information, or optimized link state routing protocol OLSR, and topology broadcast based on reverse path forwarding. Okay, so all these routing algorithms basically comes under flat routing algorithm, flat I mean proactive routing algorithms under flat routing algorithm. The advantage of proactive routing algorithm is that they can give QoS guarantees related to connection setup, latency, and other time requirements. Okay, the propagation characteristics of a certain path between a sender and a receiver can also be known in advance. Okay, but the big disadvantage of this proactive protocol is that their overheads in lightly loaded network is high. Okay, even the network is loaded lightly, as we have discussed in DSDV. Even the network may be loaded lightly, but a lot of information has to be shared about the link state. That is about the routing table. Even if there is a slight change in the network, then the routing table will be updated, and that information will be travel will be transmitted more frequently. Okay, independent of any communication, the algorithm, yeah, even if there is no communication, the algorithm will keep continuously updating the routing table. So this creates a lot of unnecessary traffic, and also it drains the battery of the mobile devices. So this is the issue with the proactive routing algorithm. To overcome this issue, some reactive routing protocols were proposed. So the two most prominent members of the reactive routing protocols are DSR, Dynamic Source Routing Protocol, and AODV, Ad hoc On Demand Distance Vector Routing Protocol. Okay, and there is also another routing protocol, Dynamic Manet On Demand. Right. So DSR and AODV are the leading candidates for standardization in IETF, Internet Engineering Task Force. Actually, up to now, there is not a clear winner. So both are the leading candidates, DSR and AODV, under this category. Okay. The advantage of on-demand protocol is scalability. As long as there is a light load traffic and low mobility, these algorithms works well. But this algorithm also works well only when there is a light load. Okay, and mobile devices can utilize longer low power periods by using these reactive protocols. That is, it won't drain the batteries. Okay. Mm, mm. But uh, uh, okay, so however, this protocol also has some disadvantages. The initial search latency may degrade the performance of interactive applications, and the quality of the path is not known a priori. The quality of the path, whatever they are going to set up these reactive algorithms, will not be known earlier. Okay, so that is one of the drawback of this particular technique, and also initial search latency may degrade the performance. So this is about the flat routing protocol. So under flat routing protocol, we have two categories, proactive and reactive. Under proactive, we have DSDV, but the drawback with DSDV is it periodically updates the link state information. That is about the routing table whenever there is a slight change in the network. So to reduce that, the other algorithms like fuzzy cited link state and Fisher state routing were proposed. And to reduce the link state information further, the routing algorithms like OLSR and TBRPF were proposed. Okay. The advantage of proactive routing protocol is it can guarantee QoS parameters, and also it can advance itself well before the transmission itself. The delay characteristics, the propagation characteristics, the bandwidth, these things will be known. But the disadvantage is it keeps on updating the link state information continuously even when there is no traffic. It creates unnecessary traffic, and also it drains the batteries. And the reactive protocols, the leading candidates are DSR and AODV. The advantage is scalability when there is light load and when there is low mobility. The disadvantage is its initial search latency may degrade the performance, and the link quality or the path quality is not known a priori. So this is about the first category of ad hoc routing protocols. The second category is hierarchical routing algorithm, right? So in hierarchical routing algorithm, the hierarchical routing algorithm will be used when there are load is high, when the load is high. Okay, because algorithms such as DSDV, AODV, and DSR only work for smaller number of nodes and dependent heavily on mobility of nodes. That algorithm works they only on for smaller number of nodes. Okay, for larger network, so especially these routing algorithms will be used for larger networks. When the network is large, then we need this type of routing protocols like CGSR, HSR. Okay, CGSR stands for Clustered Head Gateway Switched Routing Algorithm. HSR stands for Hierarchical State Routing Algorithm, and LANMOR, which stands for Landmark Ad Hoc Routing Algorithm, and the ZRP, which stands for a zone routing algorithm. Here, here the set of nodes will form a cluster, and there will be a cluster head, and group of cluster may form supercluster. Okay, and there may be a base station which controls multiple clusters. So that type of hierarchy exists in this type of routing algorithms. So you can see the right side diagram. Here you can see there is a group of nodes, they form a cluster, and in every cluster there is a cluster head. Here this is the cluster, here this is the cluster head, and here this is the cluster head, and here this is the cluster head, and a group of clusters may form super clusters, and all these clusters may communicate to a base station to connect with the internet. So in this way, this hierarchical routing protocol works. Okay. Similarly, the next type of routing algorithm is geographic position assisted routing algorithm. So here the routing will be done based on the geographic position of the nodes. Okay, this improve the overall performance of the routing if geographic proximity is known. Okay, so geographic proximity also means radio proximity. Geography proximity also means radio proximity. So one way to get the geographic information is by using GPS, global position system. So these are some of the routing protocols which comes under geographic position assisted algorithm. DREAM, distance assistant effective algorithm for mobility. Geocast, geographic addressing and routing. So geocast allows message to be sent to all nodes in a specific region, and this is done using address based on geographic information instead of logical numbers. Okay, uh, right. Similarly, there is another algorithm called greedy perimeter stateless routing. So this uses only the location information of neighbors that are exchanged via periodic beacon messages or via picky packing in packets. Okay. Mm. So these are some of the routing algorithms which works based on the geographic positions. These are the broad overview about the ad hoc routing protocols. So we have discussed ad hoc routing protocols under three categories. They are hierarchical ad hoc routing, geographic position based they are first is a flat ad hoc routing, then hierarchical ad hoc routing, then geographical position assisted ad hoc routing. Right. The next topic that we'll be discussing is uh, so in so in geographic position ad hoc routing, we also have one more routing, that is location aided routing. Okay, location aided routing is also a geographic assisted routing algorithm. This is similar to DSR, dynamic source routing, but it limits route discovery to certain geographic region. But it limits route discovery to a particular geographic region, and it based on the geographic information. Okay, fine. Now let us move on to the next topic, which is a brief overview about wireless sensor networks. Okay. See, wireless sensor networks or typically wireless sensor networks consist of sensor nodes. Sensor nodes. These sensor nodes can sense vital parameters of environment like temperature, heat, pressure, air quality, like different parameters they can sense. They sense this information and they communicate this information to the nearest sink or through the gateway node. Okay. And from the gateway node, the information may be disseminated to other places. And sometimes these nodes were generally used to sense the environment. And if any of the parameter exceeds certain threshold limit, they may create some alarms. For example, these sensor nodes may be deployed with fire sensors. And if they detect some fire, that is, if the heat parameter exceeded a certain limit, then it may give a fire alarm. Okay, or it may be used to sense whether it may be used in a what you call in a smart home kind of environment, whether the lights or fans are on when the person is not there, then it may be automatically switched off. Okay, or it may be used to track the movement of people in a particular area. So basically different kind of applications the wireless sensor networks can be used. It is also used to identify it is also used for structural health monitoring. These sensor nodes can be embedded into big blocks like buildings or bridges, okay, I mean flyovers, and this will be embedded inside the concrete itself, and it will calculate and it will keep sensing the vital parameters about the mm, particular wall, or about the particular building, or about the particular uh, a bridge, or whatever it may be. And this information it will be communicating to the nearest sink or the server, and in the server it will be calculated like whether the health of the structure is okay or not. If it is not okay, immediately an alarm can be created. Okay, so it can be, so forest fire surveillance is one of the application, structural health monitoring is one of the application. uh, okay, so like that, there are plenty of applications for wireless sensor networks, right? Uh, it can be used for flood detection, okay, water quality monitoring. If the water is increasing beyond a certain level in the dam or in the river, or some places, then you can create an alarm to indicate there is a flood. And also it can be used to sense the quality of the water. You can set some parameter for the quality. If the quality decreases beyond a certain level, then you can create an alarm that the quality of the water is poor. Okay. So, so the so basically the applications of wireless sensor networks are countless, and this is how it works. These are sensor nodes, and these are battery powered, and these sensor nodes has less. They have some computational ability. They have some memory, and also they have battery power. They are battery powered, but they can perform some minimum computations. Okay, it is not a, they do have a processor or a controlling element, but it is not as powerful as a normal computer. Okay, so they can perform some minimal computations, and also they have some minimum storage, and also these are battery powered devices. And generally wireless sensor networks are used in remote location for like forest fire surveillance, or monitoring the health of a machine. Say there may be a machine, huge machine, and some parts of the machine may not be reachable by human, so there these sensors can be dropped. So it will monitor the functionality of the machine, and it will send the data. Based on that, whether the machine is in the good condition or not, it can be identified. It also used for many military applications. Okay, whether any what you call hostile person or the opponent person is coming into our boundary or not, to identify that also wireless sensor networks are used. Okay, so basically, wireless sensor networks will be used in such applications where human reachability is tough. That is, humans cannot go there. So these sensor nodes will be just dropped from the helicopter or from the flights, and they will auto configure itself, and they will form a network. They will form a network, and generally they will communicate among themselves, and that information will be sent to the sink. So these nodes, batteries cannot be replaced in these nodes. When any sensor node fails, no, then again new sensors should be dropped in that particular place. Okay, so this is the brief overview about wireless sensor networks, right? So this is so that's it about this particular chapter, which is mobile IP, mobile uh, IP or mobile network layer. So what we have discussed in the sense we have we have discussed the goals of why a different IP protocol is required. A different IP protocol is required for wireless networks. Why can't we use the existing IP protocol that is used in the wired network? What is the drawback in using that? Right? And what are the requirements of this new protocol that we have discussed? And then we have discussed IP packet delivery, agent discovery, registration, tunneling, reverse tunneling, and also we have discussed the concept of DHCP, dynamic host configuration packet, how dynamic host configuration packet can be used in wireless networks for providing the COA, care of address for a mobile node. Okay, and then we have discussed about ad hoc routing, how ad hoc routing differs from cellular communications, and and what are the challenges in ad hoc routing. In ad hoc networks, routing itself is a challenge in ad hoc network. So we have discussed different routing techniques like destination sequence distance vector routing, dynamic source routing, least interference routing, and then we have discussed the overview of various ad hoc routing techniques like flat ad hoc routing technique, hierarchical ad hoc routing technique, geographical based assisted ad hoc routing technique. And finally, we have discussed the overview of WSN, wireless sensor networks, right? So that's it about this particular topic, and that's it about this particular session, that is mobile network layer, right? So thank you.